Okay, so mass percent can be prepared in any kind of glassware. We've been saying use a beaker. We can just set on a balance, measure everything into one container by mass. But the solution concentration unit we're going to talk about next requires a little more care in preparation and some special glassware. And this is when we talk about molar concentration. So sometimes we talk about molar, sometimes we say the molarity, and these all sort of mean the same thing for us. They mean the moles of solute per liter of solution. Now, we can think of this as a two-part unit, moles per liter. We use the uppercase M to mean molar or molarity. It's very important when you're talking about molarity that you use an uppercase M, and it's not a big M or a little m. It's uppercase and lowercase. The way that we distinguish in chemistry, the uppercase M has points. The lowercase m has humps. This is uppercase, this is lowercase. This is not big and this little m, because this is a big M, is it not? It's not that big. Okay, yeah, it's a pretty big M. And this is a little m, but this is still uppercase, and this means molarity, and this lowercase m means something different that we don't talk about in Chem 101. It means molality. But because it does have a different meaning in chemistry, it's important that you don't mess up and write this when you mean this, because I will mark it wrong because it is wrong. So uppercase M has points, lowercase m has humps when you write the letter. Now, one thing that really screws students up with their math is when they start trying to use this molarity in the fence post and they just stick that uppercase M in there. You need to break it down. If you see this, you're going to write this. Now, we talk about making the units cancel. How many milliliters are in a liter? 1,000. A lot of times we measure our volumes in milliliters instead of liters. So if you're trying to do a calculation problem where you have milliliters and you have moles per liter, you need to change milliliters and liters. So sometimes you'll see me write moles per 1,000 mils. And that's the same as moles per liter, which is the same as the uppercase M, molarity. Now, how do we prepare these molar solutions? Well, we have to prepare them in special glassware. And this special glassware is called a volumetric flask, and I brought several in here. So this is a volumetric flask. This one I think is 4 liters. And, no, this one's 5 liters. You can see that there's a mark on the neck. And for those of you, why am I not video? Oh, here we go. For those of you watching at home, if you look at this, you can see that that mark is a circle all the way around. When you're trying to read this flask, you have to put your eye like this so that all you see is a straight line. So you hold this right at your eye level so that you see a straight line, and then we fill these solutions so that the meniscus of the liquid, the bottom of the meniscus, which is often water, is sitting directly on that line when we're looking straight at it at eye level. And we get lots of significant figures from this. Now, these are individually hand-calibrated pieces of glassware, so they are very expensive. This one has a ground glass joint in the top. I brought some smaller ones as well in different sizes, and they also have a ground glass joint. When you put that ground glass joint on, these start at about $15 just for the ground glass joint. So it makes the glassware really expensive. Then each one of these flasks is individually calibrated to put that line on. So this is very expensive glassware. And because of their design, they're really easy to tip over and break. Okay, they're not that sturdy. So they come in all different sizes. I brought some different ones to show you. The giant guy I just showed you. This is a 200 mil. I use these a lot. So 200 milliliters. I brought this one as a 25 milliliter. And you'll see these have the red on there. It makes it easier to visualize that white mark on there. I brought this one because it's so darn cute. This is a 5 ml volumetric flask, and we actually have some 1 milliliters. Now, the problem with them is they're so tiny on the bottom that they tip over. They're about as thick as a pencil. So what we have to do is put a big base on them so that they sit and don't tip over. I didn't bring one of those, but they're really cute and functional and efficient. So, how do we do our calculations with these? Well, again, we use it as the two-part unit. So it's really important that you learn to write the uppercase M as moles per liter, or often you'll see me try to shortcut a step by writing moles per 1,000 milliliters. That way we can cancel the milliliters out. Okay, so let's look at this first example. There's all kinds of problems you can do with molarity. So first example, how many grams of potassium dichromate would be needed to prepare 250 milliliters of 0.1 molar potassium dichromate solution? Well, when you think about this, we know the molarity. We know that we have 0.1 moles of potassium dichromate, and we need the formula. Potassium is a +1, dichromate's a -2, so we need 2 potassiums. We need 0.1 moles per liter. We know there's 1,000 milliliters in a liter. And because this has information for us in grams, what do I need to calculate before I can start with my fence post calculation? Grams per mole, or the molar mass. So potassium dichromate is 294.1846 grams per mole. So I have to sort of think about what information do I need ahead of time. And I like to just write it all down on the page away from the numbers. And then I also want 250 mils. So it says, how many grams of potassium dichromate? As I've told you over and over, I like to start with the unit I want on top. We already saw an example today where people started with one of the numbers given and they ended up with an upside down answer. So if you use this method, you never end up upside down or backwards. So I know that there are 294.1846 grams of potassium dichromate per 1 mole of potassium dichromate. I also like to write down grams of potassium dichromate and moles of potassium dichromate, because when you do that, you don't get grams and moles of different things mixed up later on in this unit. We're going to talk about stoichiometry, and that can be an issue. So develop that habit now. And we now want to cancel the moles out. So I have 0.100 moles of potassium dichromate is dissolved in 1 liter, but I'm going to write it as 1,000 mils of solution of potassium dichromate. It just saves me a step now. And I want 250 milliliters of solution. So do you see why it was easier to just write the 1,000 mils instead of writing 1 liter and then putting in 1,000 mils per liter? Is everybody comfortable with me doing that? Okay, it saves a step. So my moles cancel, my milliliters of solution cancel, and I'm left 7.35 grams of potassium dichromate. So in this case, I was trying to figure out how much I need to make my solution. In other times, we'll be saying, well, if I have a volume, how much is in there? So you can use these in a lot of different calculations, but the key is remembering molarity is a two-part unit. Go ahead and try the next one. Let's just have you do this at your seats.